So welcome to our notes for product to sum identities and sum to product identities. The first set here will take a product of either sines and cosines, both sines or both cosines, and convert it into a sum of trig functions or a difference. Then the sum to product identities do the opposite. We start with a sum or a difference of two trig functions and convert that using the identities to a product. So let's take a look at example 1 where we'll see these identities in action. We want to evaluate the cosine of 11 pi over 12 times the cosine of pi over 12. So we have two different angles. In our identity, which we'll be using cosine times cosine, notice that there's alpha and beta. Those are our two different angles in the identity. So 11 pi over 12, that's going to be alpha, and pi over 12 is going to be beta in the identity. So when we substitute those values, we'll have 1/2 times the quantity cosine, and then we need to add alpha plus beta. So we'll have 11 pi over 12 plus beta, which is pi over 12. And then in the identity, this product becomes a sum. So we'll have a plus cosine, and now the identity asks for the difference of alpha and beta. So we're going to subtract alpha, which is 11 pi over 12, minus beta, which is pi over 12. And now we've substituted our alpha and beta angles into the product to sum identity for a product of cosines. Next, we're going to simplify. So we'll have 1/2 times the quantity cosine, and then 11 pi over 12 plus pi over 12 is 12 pi over 12, and that reduces to pi. Then we've got 11 pi over 12 minus pi over 12. That's 10 pi over 12, which reduces to 5 pi over 6. And these are special angles on the unit circle. So remember, cosine is the x coordinate at that angle, so we find pi on our unit circle, and the cosine is the x value. So -1 is the cosine of pi. Then the cosine of 5 pi over 6, here's 5 pi over 6 on the unit circle in quadrant 2, and the cosine is the x coordinate, which is negative square root of 3 over 2. So now we want to add -1 plus negative root 3 over 2, which requires a common denominator. So that would be a common denominator of 2. So in the numerator of our fraction, we'll have -2 minus square root of 3 over our common denominator of 2. And now, multiplying fractions, we multiply straight across the numerator, straight across the denominator, and we get -2 minus square root of 3, all divided by 4. And that would be the exact value of the cosine of 11 pi over 12 times the cosine of pi over 12. So we can't get that exact value directly from the calculator, but we can compare the decimal equivalents for the answer we got and the original problem to see if they match. So we want to be in radian mode, which we are, and we're going to evaluate the cosine of 11 pi over 12 times the cosine of pi over 12. And then we're going to compare that decimal to our answer, -2 minus the square root of 3 all divided by 4. And you'll see that the decimals are equivalent, so we know that our answer checks and is correct.